Hello everyone, my name is Varun and I am the instructor of the course on transportation engineering. From last few lectures, we are looking into traffic engineering, and from previous lecture we have started the traffic studies, different studies in order to find out various traffic characteristics, and will use these values in order to design traffic facilities. So now we'll move into traffic study related to prioritizing a route. This is OND study, that is origin and destination study. Before studying origin and destination study, let us see the four-step modeling which we require in order to model a traffic facility. The four-step modeling includes trip generation, trip distribution, mode choice, and route choice. Trip generation is the step which involves in generation of trips. Generation of trips means whenever you are present in a locality, if it is a residential locality and you want to go to your workplace or any recreational place or any other place, you will start your trip from your locality. Whenever you are coming back from your workplace, your industrial zone, you will start, or your trip will be generated from that place only. So trip generation has a purpose. Trip generation involves the purpose of the trip. From trip generation, we can classify the trips based on the timing, based on the income group of the society, based on the different zones which are being established for the study. This traffic modeling is done in two ways. In first way, we will do study based on your household trips. Household means a house in which the family members live. So how many trips are being generated? What are the distribution of those trips? What are the mode choices they have? What are the routes they follow? So this gives you a very simplified, very exact value to model. But it is very difficult to have trips from each and every particular household. So that's why we defined zones on the basis of different your variables like income group, like land use pattern, like utility areas. So the zones are divided, and then these zones are used for your study area. Now in this type of modeling, you will use these zones to study your trip generation, trip distribution, mode choice, and route choice problem. So through trip generation, you start with start of trip. It can be your house, it can be your workplace, it can be any recreational area, it can be any religious area. Then trip distribution. There is a zone, there are various, this is, let us say this is zone, these are destinations, destination 1, destination 2, destination 3, destination 4, destination 5. These are various destinations. So your trip will start from this zone, and then it may distribute to various destinations. It may distribute to various destinations. So this is your second step, trip distribution. So we need to find out, if a trip is generated, what destination is preferred, or what destination is used for more number of trips. Then we have mode choice. Mode means what type of vehicle or what mode of vehicle you use in order to reach your destination. Mode can be motorized vehicle, can be non-motorized transport vehicle, it can be your public transport, it can be your personal transport. So in this way we can have the mode choice things. So while you want to reach from Z to D2, what mode you choose is considered under mode choice. Then route choice. While we are going from Z to D2, you have one route here, another route, this one. Then you may have a third route, this one. You may have another route from D3 or via D3. So which route is preferred in order to reach your destination? This comes under route choice. So these are the 4 steps which we use for transportation modeling. Now, in order to study the route choices, in order to study the trip distribution, we need some kind of study arrangement. And that study arrangement here is known as origin and destination study. Here also, if you see, if Z zone is your starting point, so this is known as origin, and if D is your final location to reach, this is your destination. So in order to find the priority of the route, or in order to find the priority of the destination, we will use the origin and destination study. So let us see what is origin and destination study. Origin and destination study is used to determine the number, the origin and the destination of a vehicle for a concerned zone for the study. Whenever we are doing origin and destination study, it will tell us about the number of vehicle, number of trip, the origin of the vehicle, the destination of the vehicle for the study zone. It gives us the information like actual direction of travel, selection of route and length of the trip. This is what we want. The direction of travel will give us the route choice, or it will tell us about the destination. The selection of route and the length of the trip, this will also help us in order to design various traffic facilities. Then we plot this data obtained by this origin and destination study using desired lines. There are other methods also like contour lines, but desired lines are most favorable one because they will give us visualization that which route is used more. So what is desired line? Desired line is the trip, or it is a straight line which denotes a trip from location 1 to location 2. If location 1 and location 2 has n number of trips, then the thickness of desired line will be proportional to that n value. Means more the number of trips, more the thickness of desired line. So if we compare route 1, route 2, route 3 between one origin and destination, we will be able to say that the desired line having maximum thickness is the priority route. So this is how we define the priority route, or we define the route choice of the commuters. Let us see the method of collection of OND data. How do we collect OND data? These are few methods can be used to collect OND data. What OND data is required? We need the number of vehicles, number of trips, the direction of trips, origin and destination of trips. You can also calculate the purpose of trip, or you can also ask the purpose of trip. You can also find out the type of vehicle which we are using for the trip. So there may be n number of questions, or depending on your desired modeling, you can ask the number of questions from this OND data. So this is the roadside interview method, in which you find a suitable place and you try to engage some of the commuters, and then you'll ask some questions about your desired questionnaire. Like, when did you start your journey? What was your starting point? which route you choose, why the preference of route is this, what is the difference which you find in the level of service of route 1, route 2 and route 3, what is the time to reach your destination. So these may be the questionnaire which you may ask from roadside interview method. Another one is license plate method. This is a very easy method in order to collect the data. In this process, you place various surveyors onto the control points of your zone. Each and every vehicle is noted down by its license plate or its registration number, whatever is available. License plates are already visible, so license plate numbers are noted down for each vehicle passing through that control point. Then that data is brought to the office and processed in order to see which vehicle started or entered the zone with a point and left the zone with another point. So this need a lot of computations. Computations are tough, but data collection is easy. So if you have number of or the manpower more and a very good computational arrangement, then you can use this license plate method. Next one is written postcard method. Written postcard method is a method in which you take a postcard, you write the return address, the ticket which is required in order to get the postcard delivered, and then you write the questionnaire behind that postcard. You give these postcards to the commuters, they may return it whenever they are free and they will be able to fill the postcard. Whenever they fill the postcards, they may take their own time without any hurry and give the correct answers for the questionnaire. So this is a very effective method, but we have seen that most of the postcards are being ignored by the commuters. But if we collect data with this method seems to be the most efficient one if the data is collected, because if a commuter is taking time to answer with a postcard with his own time, then it seems to be having the correct answers. Then another one is tag on car method. It is similar to the license plate method. The tag on car method, there are different colored tags which are placed on the vehicle whenever it is entering a zone. Then on another control point, when another surveyor is standing there, he will see the tag on the moving vehicle and he'll note down this colored tag, X number of vehicles with red colored tag cross this control point, Y number of vehicles with blue color tag cross these points. So if this is a zone, these are few control areas where vehicle enter or leave. If we put blue tag here, red tag here, yellow tag here, and if we see how many number of blue tags are moving out of here, how many number of yellow tags are moving out of here, how many number of red tags are moving out of here, how many number of yellow tags are moving out of here, so we will be able to see how many numbers of vehicle are entering from this location and exiting from this location. So this will tell us about the number of vehicles. This is a very effective method, equivalent to license plate method. Also, this required less computation as compared to the license plate method. So this method can also be used in order to find out the desired destination for any vehicle. Another interview methods are home interview method and work spot interview method. You can choose a sample size from a zone, and from that sample size you can interact and ask the desired questionnaire. This is also effective method if the commuters cooperate. So these methods are used in order to collect the origin and destination data, and then using this data we prepare the desired lines. Thickest desired line will tell us about the more the thickness of any desired line. This means more this route is used by the commuters. So this is all about your origin and destination study. So this is your desired line. Mostly the question is asked from the desired line itself. What the significance of desired line? How will you, or which of the following data presentation is done in origin and destination study? You will be having a trend chart, you will be having option as a desired line, you will be having an option as your AADT. So AADT value, your trend chart value, these values are for traffic flow. You know that for origin and destination study you have desired lines. You may be asked, there are 4 routes. One of the route is having 1 mm of thickness of a desired line, another route is having 0.5 mm of thickness of desired line, another route is having of 0.25 mm of desired line thickness, and one route have a very negligible thickness of desired line. Which of the route will be preferred in order to provide funds for upgradation? So if you want to provide upgradation, you will choose a route which is uh, used by commuters more. So a route which has the maximum thickness of desired line, that is 1 mm from the question, that will be provided the funds. So this kind of question, aptitude question, can also be asked from desired lines. So this is all from your origin and destination study. From the 4-step modeling, your trip generation is studied using your origin and destination data, because origin is one particular characteristic of your OD study. So this is included from trip generation. Then trip distribution is also studied during your OD data, and your route choice can also be studied using OD data. Mode choice depends on your questionnaire. Whenever you are using your questionnaire, if you ask what type of vehicle or what type of mode of transportation you use, if it is a public transport or if it is a personal transport, non-motorized vehicle, or what kind of public transport you use for the classification, you may ask these questions also. So if you ask these type of question in your questionnaire, then it will be easy in order to find the mode choices of your commuters or your study area. So this is how we use OND study data in order to find out your 4-step modeling. Next, we start with your parking studies. Look, parking is a very crucial operation which we see. This can be done on the road or off the road. You may call it on curb parking or curb parking. Another one is off-road parking. The curb parking is one which is to be designed in a proper way, because off-road parking, off-road means whenever you are traveling on this road, away from this road a parking space is provided where you can park the vehicle. Now whenever you are parking your vehicles away from the road, the maneuvering of this vehicle will not affect the road. Maneuvering means movement. Whenever you are parking, you turn your vehicle in one direction, then take reverse and then turn again. So this is known as maneuvering. Maneuvering is moving through the traffic. So you need not to do maneuvering process through the traffic whenever the parking facility is situated off the road. But whenever it is on curb or on road parking, then you should focus on the maneuvering or the arrangement of your parking vehicles. So let us see different type of parkings. This is a road. Parkings are provided on both the sides, on the curb or off the curb, but on the road itself. So this space should be utilized for parking without interrupting the vehicle moving on the road. This kind of parking is seen, or on-road parking is seen on arterial roads. What are arterial roads? These are the major roads present in the urban areas. Expressways, they are connecting roads, but arterial roads are the major commuting roads on the urban traffic path. So there are n number of parking arrangements you can use, but the major parking arrangements which we can see is parallel parking, the parking in which vehicles are parked parallel to the roadside. This is the roadside and vehicles are parked parallel. So this is the parallel parking. Another one is inclined parking, or let us say another one is perpendicular parking. Perpendicular parking. Look, if this is the roadside and I park my vehicle in this way, my vehicle is facing the roadside, so I am utilizing a space equal to the vehicle length on my curves. So this type of arrangement is known as perpendicular parking. And then there are arrangements from parallel to perpendicular. Means we will move from parallel to perpendicular and will make some angles step by step, as 30-degree angle parking, you can see here, 45-degree angle parking, 60-degree angle parking, or 90-degree angle parking. That is perpendicular parking. So these are the parking arrangements we are going to see, and we'll see how these arrangements can affect your traffic movement on the road. Parallel parking is the most suitable type of parking whenever the space on curb is not available. You can see the curb space which is utilized is equal to the width of your vehicle. It is taken as 2.5 meter. The width of vehicle is taken as 2.5 meter. So the curb space which this vehicle will use will be equal to 2.5 meter. This arrangement has a problem that the number of vehicle which we can park here is least. Means as compared to other arrangements, the number of vehicle which we can park here is least in number, because the area which is used for parking is parallel to your curb, and it will be equal to the length of your vehicle. Vehicle is parked parallel to the curb, and it is the length of vehicle is taken as 5.4, and the total area which one vehicle will require for parking is 6.6 meters, because we need some buffers in front and back of a vehicle while parking. We cannot park these vehicles bumper to bumper. For maneuvering process, maneuvering means for moving out this vehicle from the parking or placing this vehicle into the parking, we need some space. So the space provided is 1.2 meter here. The length is 5.4. The total width which we consider that a vehicle will require is 6.6. So 1.2 meter is required for every vehicle for maneuvering it. So this is the total number of vehicle which can be parked in L length of your parking area. If I say one vehicle will require 6.6 meter length, then for L length, how many number of vehicle will be parked? This is divided by 6.6. Similarly, there are spaces created between two vehicles. The parking is done such that the space is not provided in front or back of every vehicle. It is provided in between the group of two vehicles, like vehicle 1 and vehicle 2 is parked here, vehicle 1 and vehicle 2 is parked here. This is the space which is provided. So this is just double of the space which we see in single parking. Because of this space, the vehicle this can move or can use front maneuvering. The vehicle here will use back maneuvering, and they both will be able to park in or park out of this parking facility. So this is how this parking can also be arranged. But what you need to remember, the number of vehicles which can be parked in a parallel parking is equals to L by 6.6. This is an additional value. This you need not to remember. Another parking is 30-degree parking. The angle between the side of the vehicle and your curb is 30 degree. Now, from this parking arrangement, we can say that the distance between two vehicles is taken as 5.1 meter. Although this is not the total length. So the length which these two are intersecting is counted in another vehicle's parking space. So the parking space required for one vehicle is 5.1 meter of length. This parking space of another vehicle is 5.1 meter of length. But for the last vehicle, we need some space, as this intersection which we are using for another vehicles, we are using this for next vehicle, but for the last vehicle there is no another vehicle coming. So the intersecting space which we have here is 0.85 meter. So how many number of vehicles will be accommodate in this L length of parking space? 5.1, 5.1, 5.1, 5.1. The vehicles are using 5.1, but some extra length 0.85 meter of this L. So we will subtract 0.85 meter of this L, and now remaining space will be distributed in the vehicle per vehicle as 5.1 parking space. So dividing L minus 0.85 meter by 5.1 will get the number of vehicles which we will use in which we can park in a 30-degree angled parking. You can see one another value is visible here. This is your MS value. What is MS value? MS is your maneuvering space, the space available for maneuvering. For parallel parking, or space required for maneuvering, the parallel parking has the space of 6.2 meter required for maneuvering. Means whenever you are parked here, another vehicle which is parked just behind you, you need a space to maneuver. You will come here and then you will move. So what space is required here? This is 6.2 meter for parallel parking. But whenever you are in angled parking, your maneuvering will be in this angled direction. So this will take more space. So you can say with increase in the angle of your parking, your maneuvering space required will increase. So maneuvering space for 30-degree angled parking is 8.3. Let's look into the maneuvering space of parking with steeper angles like 45 degree. The maneuvering space is 9.7. If it is 60-degree, maneuvering space is 11.6 meters. So as we are increasing the angle to get this 90-degree, the maneuvering space required is 13 meter. So you can imagine how much space, how much more space on the road we require while providing a angled parking. So we will say that if there is less space available on the road, we will use parallel parking. But if we have enough space available on the road and we want more vehicles to park, we will use this angled parking. If we see for angled parking of 45-degree, we have the spacing will reduce the value of spacing. For 30-degree, it was 5.1 meter. Now it is reduced to 3.6. Then for 60-degree, it is again reduced to 2.9. And for perpendicular parking, it will be reduced to the width of the vehicle. So this is an arrangement in which we are increasing the number of vehicles, but we are reducing the, or we should say that we are increasing the maneuvering space also. We are reducing the maneuvering comfort, or we are reducing the interruption, or we are increasing the interruption with the running traffic. So whenever there is lot of space available on the road for parking, we can use parallel parking, because we can use lot of space for maneuvering, that is 13 meter for this perpendicular parking. Whenever less space is available, we will use parallel parking and will park the vehicles parallel to your curb side. This 45-degree angle parking is considered to be the best parking arrangement, because if we compare with parallel parking, it has more number of vehicles. If we compare with perpendicular parking, it needs less maneuvering space. So it is the optimum parking arrangement we can use for parking on the roadside. So there may be a question asking which of these is the best arrangement for parking on road. So you can say the 45-degree angle parking is the best arrangement for parking on the road. If the question is asked that which type of parking arrangement should be used in order to accommodate more number of vehicles, we know that as the angle increases, the number of vehicles which we can accommodate in the parking will increase. So for a parking arrangement of 90-degree, we will have most number of vehicles. There may be a question that if the parking space is not much available on the curb side, which type of parking is the most suitable one? So you will say that parallel parking is the most suitable type of parking for an area where not much space is available on the side of the road. So this kind of questions you will find your examination for 1 mark. So you need not to remember all the values, but for parallel parking, for 45-degree parking, and for 90-degree parking, these values should be remembered, because these are the values which has more probability to be asked. If you remember these values, this is well and good. This is 3.6, not 36. This is 3.6. Okay, so this is 3.6 meter. So you can use these values to calculate the number of vehicles, or if the number of vehicles are given and you will be asked which parking is more suitable for a given length of x distance, you will be able to calculate using the x distance that which parking can accommodate the given number of vehicles. This is how parking studies can be used for your solutions. Next study is your accidental study. Accidents Accidents means a collision between two vehicles, a vehicle and a roadblock. The two vehicles which are colliding, there may be a condition when one vehicle is stationary, another vehicle is moving, or both the vehicles are moving in same direction, or both the vehicles are moving in opposite head-on condition, or both the vehicles are moving in different direction. So accidents when one vehicle is moving, collides with stationary vehicle. Another condition, vehicles moving in opposite direction collides head-on. These vehicles are moving. This is moving in this direction. This is moving in this direction. They have a head-on collision. Vehicles from different direction collides. What is different directions? Like one vehicle is coming on this road, another vehicle is coming on this road. The direction is different, but whenever they'll reach this intersecting point, they'll collide with each other. So this may be another condition. And finally, vehicle may collide with stationary object. Like pole, electricity pole, your stone block, your parapet wall, etc. So there are these various conditions in which accidents may occur. Why accident does occur? Whenever we are not able to stop before collision, the situation which we see is known as accident. If we are able to apply brake and stop ourselves just before colliding, then there is no accident. So what we can do, if we are not able to stop before colliding, this means our speed is comparatively higher as compared to the distance required for stopping. So we want that speed, initial speed, so that we can regulate this condition. If the speeds are higher, we can provide speed breakers. If speeds are higher, we can give warning signs. If a location which is having a lot of accidents, if we can study the cause of accident, then we can reduce the number of accidents, we can reduce the severity of the accidents. This is why the accidental studies are performed. So what are the values which we need in order to find out the speeds? What we have on the route, what we have available, data or conditions have after accident. The available data or conditions we have after the accidents. First is your skid marks. What are skid marks? Whenever we apply brake, let us say this is my object. I am moving from here with the velocity of v1. Here I see this object. What I will do, I'll try to stop my vehicle before colliding this object or a stationary vehicle. I'll reach here and collide with the vehicle. I had already applied the brake but could not stop till here but my velocity reduces from v1 to v2, and because of application of brake, here we take one assumption that braking efficiency is 100%. Means when we apply brake, the brakes will choke the tire or it will seize the rotational motion of tire. This means the motion will be longitudinal, and if without rotational motion there is any longitudinal motion, then you will definitely see skid marks. So when we applied brakes at this point and we reach here just before the collision, so the skid marks which are visible here, the S skid marks 1, so this is skid marks 1, which we will find on the road after the accident. Now after the collision, this object will move with this vehicle the same velocity, and they will travel some distance and then they will stop. So after the collision, the speed of your vehicle, just after the collision, the speed of your vehicle will be v3, and finally the speed of the vehicle will be equal to 0. So after the collision, till this vehicle stops, there will be skid marks visible, and those skid marks will be S2. So now we have two types of skid marks. One skid mark which is visible because of the braking operations, and another skid marks which are visible because of the collision itself. After colliding, I will stop after some distance. So the distance which we covered before stopping is known as skid mark 2. So if we have these values on the road, we will use equation of motion. Which equation of motion? V square is equals to u square plus 2as. What is v? V is your final velocity or speed. What is u? U is your initial velocity or speed. What is a? A is your deceleration. Talking about a, do we know a value? Yes, we know the a value because the deceleration is because of the friction. We have already seized the vehicle. Now we are deaccelerating to lower speed because of the friction itself. So we have seen the braking test. There we found that F value is equals to A by G. So we can calculate the coefficient of friction F or value of A from coefficient of friction F, that is Fg. This you should remember. And S is your skid distance or skid mark, length of skid mark. What else we have? We have a momentum equation. What momentum equation we have? If in a direction mass m1 is moving with the velocity v1 and mass m2 is moving with a velocity v2, after collision this combined mass may move with the velocity or we can write as V, this mass 1. Let's call this object as A and we'll call it VA1, and this is mass 2. Let's call this object B and this velocity will be VB1. If VB1, if B vehicle is stationary, we can call this value as 0, and finally they will move with a constant velocity after collision. The collision velocity, the velocity after collision is equals to V3. We can write VA3 or VB3, doesn't make any problem, or we can also write this equation as after collision as, or this is just before collision, so we can write this value as VA2, because we are comparing the movement condition just before the collision and just after the collision. So just before the collision the velocity is V2, not V1. V1 is the initial velocity. So we have here VA2, vehicle A, VB2. If this vehicle is moving, well and good. If it is not moving, then it is 0. And VB3, or we can write as VA3 plus M2 VB3. So this is the momentum equation which we can use for calculation of velocities, because this is the value which we need for our accidental study. Let us see case 1. Case 1 in which a moving vehicle collides with a stationary vehicle. Case 1, a moving vehicle with a stationary vehicle. You can take it as stationary vehicle or an object. What is happening here? This vehicle is coming. Both the vehicles are moving in the same direction. This vehicle is coming here with the velocity of, let us call this vehicle A. This is vehicle moving with velocity of V. Here we have a stationary vehicle B. This is stationary, or you can say this is moving with the velocity of V, V1. We can take same case in one case only, stationary vehicle or moving in, and same vehicle moving in same direction. So if it is stationary, we will call VB1 as 0. So when this A vehicle see that there is slow moving vehicle or a stationary vehicle VB or B, it will try to stop itself before colliding. So it will apply brake, and just before the collision it will be able to reduce its velocity to VA2. Now the distance covered by this vehicle is how much? Distance covered by this vehicle is S1. After the collision, these both vehicle, after the collision, VA, VB, both the vehicles move in the same direction, and this direction, the velocity V will be equals to VA, and finally they will stop itself. Velocity equal. Before telling you the collision, we should one more thing. This is a scenario. I think this you must have understood. But why these two vehicles are moving? This is an assumption, and the assumption says that the collision is plastic. So let me first tell you what is elastic and plastic collision. Here we have a value which is known as coefficient of restitution. This coefficient of restitution is equal to velocity difference after collision, velocity difference between two vehicles after collision divided by velocity difference of two vehicles before collision. Means if velocity of vehicle A is VA3 after collision and velocity of vehicle B is VB3 after collision, so the difference between vehicle 1 and vehicle 2 velocity before collision, VA2 minus VB2. This ratio is known as your coefficient of restitution, and this is denoted by a symbol E. For a perfect elastic collision, means the E value is equals to 1. What is perfect elastic collision? Perfect elastic collision means if B vehicle is stationary and A vehicle is colliding with the velocity V, then because of this elastic collision, your B vehicle will start moving with the velocity with which your A vehicle collided, and A vehicle will just come to rest after collision. When you were child, you must have played those glass balls, kanche. So whenever we are marking the glass ball with very high speed, the glass ball which we use stops after colliding another glass ball, and that another glass ball with which this collision has happened, it moves with a higher velocity. It is equivalent to the velocity with which we threw that first glass ball. Or whenever you are playing pool or billiards, you must have seen the white ball. When it collides with another ball placed in the pool or on the table, then it sometimes hit first ball and stuck at the same position. The ball which is being struck start moving with the velocity with which the white ball hit or hits it. So this type of collision is known as perfectly elastic collision. If you say the difference initial velocity of VA is V and VB is 0, means B is stationary, VA is moving with the velocity V. After collision, this A velocity will be equal to 0 and B will start moving with velocity V. It is this condition when the separation or velocity separation and velocity approach is same and the E value will be 1. There may be another condition when two vehicles are moving, both are moving, but after the collision the velocity difference remains same. So this kind of condition is known as perfectly elastic condition. Another condition is for a perfect plastic condition. We have this E value is equal to, means this E value or the numerator is equal to 0, because denominator cannot be 0. If it is 0, this means there is no collision. If both the vehicles are moving with same direction with same velocity, there is no collision. If they are moving in opposite direction, then velocity approach will double. So I am not talking about the same direction, opposite direction. We are talking about the same direction movement of the vehicles. So here numerator value is 0 because after the collision, both the vehicles start moving in the direction as a combined mass with same velocity. I wrote here A and B because I assumed this collision to be a plastic collision, where both the vehicle are combined and then they are moving with the velocity VA3. So this is assumed to be a plastic collision. Whenever there are no visible skid marks, this means this is a free collision. No resistance was applied to stop this collision, or no resistance or no brake was applied in order to stop the accident. So we assume, after looking at the skid marks, that the it is not a free collision. There is skid marks. This means driver tried to stop before the collision, and here A and this position A, these has different velocities because of skidding of the vehicle, application of brake, and after the collision, it will the assembly will stop at a distance S2. Here the brakes are already applied, so again we will see skid marks comparatively smaller than S1. So this is the scenario when first moving vehicle collides with another vehicle, either stationary or moving. What we need to do, we need to find out the velocity VA1, because the collision has happened because of this velocity only. If it is less, then after application of brakes, driver would have stopped the vehicle, but the vehicle is in running condition, that's why the collision has occurred. So let us take condition 1. Before collision, we have v square is equal to u square plus as. So your initial velocity, your we want va2 for collision. This is va2. Initial velocity is va1. We are deaccelerating with the acceleration or retardation of fg. We have skid marks of s1. So this is equation 1. Using the same equation after collision, the final velocity after collision for some time equal to 0. What is the initial velocity after collision? This is va3. After collision, the velocity will be va3, and the skid mark which we found after collision is s2. So we have this equation. Okay. From this equation, calculate value of va3. It's easy to calculate the value of va3 from here. We want va1. So in order to find out va1, we will need va2, because in first equation both these values are unknown, otherwise all other values are known. Okay, so what else we have? We have this momentum equation. We can write this momentum equation as m1 a m1 va2, write it as va plus m2 as vb2 equals to m1 plus m2 va3. Here, if vehicle 2 is stationary, we can write it as 0. If it is not stationary, we can again make the use of this momentum equation for vehicle B and write an equation in order to find out VB2. But as we consider this vehicle as stationary, we will write it as 0, and our VA2 will be equal to M1 plus M2 by M1 multiplied by VA3. VA3 we have already calculated from equation 2. Now we have VA2. So from equation 3, solve equation 1 to find VA1. So we can calculate VA1. This is the initial velocity with which our vehicle is moving, the colliding vehicle is moving. So in order to regulate this velocity, we need the value of velocity. So this is the first case. I want you to solve a question and write the solution in the comment box. We will discuss this, or you will find the solution in your Telegram group. Here the skid mark S1 is equals to 60 meter. Skid mark S2 is equals to 25 meter. Weight of first vehicle is equal to 60% of weight of second vehicle. We want you to calculate the initial velocity of colliding vehicle. So let me know the value of initial velocity in kilometer per hour for vehicle 1. So you can use these equations, these concepts in order to find out PA1. Now let us discuss another scenario. When two vehicles collide when they are moving, this is case 2. When two vehicles moving in different direction collides. Like this is the direction of motion of vehicle 1. This is the direction of motion of vehicle 2. So this is direction of vehicle B. This is direction of vehicle A. Vehicle B should be moving in this direction after or without collision. Vehicle A should be moving in this direction if there is no collision. But after the collision, vehicle A tend to change its path to this direction at an angle of theta A, and vehicle B tend to change the direction from its original direction as theta B, this direction. All the values are same, VA1, VB1, initial velocity of vehicles, then VA2, VB2, velocity of vehicles before collision, VB or VA3, VB3, velocity of vehicles just after collision. So these are the values. M1 and M2 are the mass of these two vehicles A and B. We can easily write the equation for vehicle A. We have VA2 square is equals to B2 square plus 2 FG into S1, SA1, because there will be skid marks SA1, there will be skid marks for vehicle B SB1, similarly skid marks after the collision SA2, and for vehicle B SB2. So the same equation which we have already used in last case, this is not B, this is A1. sorry for the error. Now we have corrected. This is a VA2 square VA1 square plus 2F into G SA1 0, because final velocity after the collision will be 0, but just after the collision the velocity was VA3 square, and the skid marks which we found after the collision for this vehicle A was skid marks 2. Similar equations can be used for vehicle B. This is VB2 square, that is the final velocity just before the collision, VB1 square plus 2FG, this is G, SB1, and equation after collision will be VB3 square plus 2FG. The skid marks after collision for vehicle B is this. Now we have 4 equations, but we have these 3 and 3, 6 unknowns. So we need 2 more equations. So let's have let's do it on another slide. Conservation of momentum x direction. So what we have in x direction, look at the diagram. We have vehicle A moving in the x direction, but after collision we have a component of vehicle A velocity and vehicle B velocity in x direction. So we can write for A direction, for x direction, m1 v a1 is equals to m1, because after collision this will be equals to, after collision this component here will be VA3 cos theta A and VB3 sin theta B. So we can write here VA3 cos theta A plus M2 VB3 cos it is sin theta B. This is equation 1. Similarly, for y direction we have, in y direction we have this B vehicle moving with a velocity of VB2. Okay, I'm sorry, this is VA2 because we are comparing just before the collision and just after the collision. So just before the collision this is VA2. Okay, so this is VB2 just before the collision, and after the collision we have 2 components here of velocity, that is VB3 cos theta B and VA3 cos theta A. So this we can use for our momentum conservation. M2 VB2 is equals to M1 VA3 sin theta A plus M2 VB3 sin cos theta B. This is equation 5 and this is equation 6. So we have already 4 equations here: equation 1, equation 2, equation 3 and equation 4. So 4 equations are here, 2 equations from conservation of momentum. We can find all the 6 values of velocities: velocity, initial velocity, before the collision velocity, after the collision velocity for A, and similar velocities for vehicle B. So we can regulate these velocities in order to avoid this collision. So this is all for now. We have today studied about the 4-step modeling. Then we studied the method to do 4-step modeling, that is origin and destination study. What kind of surveys or methods which we can use in order to do origin and destination study. Then we studied about the parking facilities and how these parking facilities are provided for different kind of conditions. What are the values of maximum number of vehicle which you can park in any parking facility? Which type of parking facility is best for what condition? What is maneuvering space? So this is what we have seen today. Then next we studied about the accidental studies, and we saw various conditions for accidents and for calculation of the values. So thank you so much for now. We'll meet in next class with intersections and intersection designs. Thank you so much.